Today, we're going to focus on specific heat capacity and latent heat and how to handle questions like that, right? So, let's say I give you a block of ice and I want to heat that ice, right? Two main things would happen to that ice, right? If I were to heat this container with ice, anybody can say what's the first thing might happen to the ice? Provided the ice at 0 degrees, the first thing that might happen to the ice, right? This is stage 1. The first thing that will happen to the ice is that the ice might become water. That's okay? That's stage 1. So if I heat it, it will become water. But when it melts, and it now melts, there is no temperature change. Right? So all of the energy I applied to heat up the ice just melted. And then the next stage, let's call that stage 2. When I heat the water now, keep heating the water, of course. If I keep heating the water, then what will happen is that the water will start to increase in temperature, right? So let's just put theta. Theta means some larger value, right? So the water becomes hotter. If I heat it further, what will happen? It'll become steam, right? If I keep heating the water becomes steam at 0 degrees Celsius, right? Let's call this stage 3. All right, so if I keep heating ice will undergo 3 possible changes, right? If I heat it, it will melt, become water. If I heat the water will start to increase in temperature. And then if I heat that hot water, and there's a point when it will turn to steam at, it will turn to steam at 100 degrees Celsius. All right? So we need to understand the difference in these stages, right? I'll do it graphically again first. If we have temperatures, and this goes for any substance, right? If we have temperatures in degrees Celsius, and we have time, if I start up here at 0 degrees Celsius, and it's ice, if I heat the ice will stay at 0 and become water. If I heat the water will heat until it reaches 100. And if I continue to heat it, that water will now become steam. That's okay? So if you look closely, it underwent 1, 2, 3 stages. All right? The first stage, we call that a change in what? A change in state or a change in phase. So that is called a change in phase. The second state, did it change in? Second state here is a change in temperature. And lastly, when I heat it even further, it changes in state again. Right? So there's a change in phase or a change in state. Everybody okay with that? Right. So basically, we are applying energy. But the energy doing 2 different things. The energy change in the phase or the energy change in the temperature. Are you okay with that? Right? So whenever I heat something, and I apply energy to it, and it changes phase, that energy is given by the mass of the substance by something called latent heat. Right? L is what we call latent heat. Right? So if I wanted to find the energy required for this, I need to multiply the mass of the substance by something called latent heat. Okay? Or, in other words, latent heat, if I rearrange this formula, is the energy required to change the phase of a particular mass. You okay with that? I just rearrange this formula here, right? So latent heat is the energy required to change the phase of a particular mass. on the other hand, if I had a temperature change, the energy required for this temperature change is mc delta theta. And the C is what we call specific heat capacity. Right? Real simple, exactly what the words mean. The specific amount of heat a substance could actually take. All right? Before temperature starts to change. So specific heat capacity is the amount of energy, I just rearranging this formula, the amount of energy required to change the temperature of a particular mass. That's okay? Yeah. So two things we learned today. Anytime we're dealing with temperature change, mc delta theta. Anytime we're dealing with phase change, ml. Right? So what we formula here, Josh? What do you think? What do you think the formula will be here during a phase change? Is equal to what? Still on the board, Josh. E is equal to m by latent heat. That's okay? Right? You recognize there's two different types of phase change, right? One is solid to liquid and one is liquid to gas, right? So there are small subscripts that can help you differentiate them. If you see an F, that's solid to liquid. If you see a V, liquid to gas. All okay with that? Yeah? So these are the things that we need to know to handle this part of this part of the question. All okay? Copy it down. A nice little summary of everything. What? Take it up, take it. You have space in front, you can come close if you want to. You can see it.
Yeah.
Sorry. All right, so let's give it a little try. Everybody have that, right? Okay. When doing questions like this, you don't necessarily have to draw the graph, but I like the graph because we can always show you the different stages. All right. So I'm gonna give you one where I'll give you a mass of ice, and they want the energy required for it to reach steam. Okay. So the question will be how much energy is required to take ice at 0 degrees and convert it to steam at 100. All you have to do is to work out phase one, work out phase two, work out phase three, using the values they give you. All right. And then I will change it around. All right. So let's take a look at this here. Now, huh? Energy. Oh, then there's the best I can do there, right? Sorry about that. Take a pick and send it now on the group because you can't see it. Stay there. And to the group. Yeah. I have the numbers. Stay there. And if you're not on the LMS, right? She sent well on the group that was Google form and she will send the email. I know I did the group or no? I think about see if I will shoot it and see if any of them message email on the group to leave. Message on Telegram problem. Right. All right, so write it down. Right, take a look picture. Take a look picture and write it down. You could use the same graph volume, right? Just one thing I want to point out. The mass is in what? The mass is in grams. And look at all the values they gave you. The mass is in grams, but all the values they gave you are in kilograms. So please remember, you have to work in kilograms, right? Go ahead. Go ahead. So they gave you 25 grams. Take your time. Watch. It's the exact thing. You didn't start at any different temperature. You start at 0, you become water, you heat it, you become water at 100, then it becomes steam. That's okay? So the exact thing, 1, 2, 3 formulas. Everybody okay with that? You have the mass and you have all these values right on the right there. Okay? Yes? Try it. If you can like I'm doing in 5 minutes. Take your time, take a 5-10 minutes and work it out, right? Yeah. Oh yeah, perhaps this. How let's plug it in half, plug it in 830 and look at the top. Right, you're doing a calculation 3 times. How would look in Kelvin here? All right, so just to make sure you're doing the right thing, right? As I said, it's the same thing, right? It's the same going to here, coming up here, and then coming to here. Right? Stage 1, stage 2, stage 3. So the energy for stage one is a phase change. So it's M by LF. M is how much? M is 0.025, right? Divide everything by 1,000. Well, which one here is fusion? Last one. So that's 3.4 by 10 to the 5. That's it. You are done. Right? Do it for the second stage, do it for the third stage. Take your time. Oh, right? Do it for all 3 stages, right? Well, underneath, yeah, just give it. Right, next one, E is equal to MC delta theta. As I said, C is specific heat capacity. Remember, it's water, yeah? So don't choose the first one. Why I can't choose the first one? Because remember, it melts, right? So it's no longer ice. So you can't choose the first one. So it's 0.025 by C. C is 4.2 by 10 to the minus 3 by temperature change. What's the temperature change in stage 2? 100, right? It went from 0 to 100. So the temperature change is 100. And last thing, E is equal to MLV. So that's 0.025 by LV is here. 2.3 by 10 to the 6. Add them all up, and you'll get your final answer. I want you to notice, right, that we did not use everything. You recognize that? So you gotta know what you're using, right? Don't assume because they give it, you have to use all of it. Take your time, quickly calculate tomorrow you get please. Take your time, quickly calculate tomorrow you get. How much is that? Can we have a total? 76500. Does it? What's the SI unit? Huh? Why we divide it? Oh, add it up. That's a line to add up. How many times we draw a line add up? Those who have labs, I'll let you all go at 10 minutes early, right? I want to run through, make sure you have the labs, and I want I can stay for a little bit, so I want to help all a little bit. Huh?
No.
Ready? Anybody confused? The hardest thing is figuring out which formula to use, and you only have 2 to choose from. You have a 50% chance of getting it right. Right? So you should guess one, right, Nuria? All right, let's go again. Anybody write it? You write it down. Go ahead. It's not, it's like so. Upside down. All right. I'll sing it again. Yes, ma'am. These are general sense. Would understand all in general sense. Then you have that structure. Yeah, so it's based on the field. Hold on, Elia. Let's see. I'm looking for one that will be kind of very clear. I did best I can do that. Yeah, no, let's take audience. Yeah, let's take audience. Wait, technical. All right, let's start. We'll do this one together. Right? We'll do this one together, right? Take a little read. If you can't see, you can log in. Or else, sorry, yeah. I try to do a list of questions and then answer so you will have it, right? I get so many here, but I don't know what year. That's it, the problem. Ready? So they give you a block of ice and they give you the mass in what? They give you the mass in kilograms. So we have no conversion to do, right? Because look at the specific heat capacity. That's also in kilograms as well. All right. So they give you 22.5 kilograms and a temperature of what? -10. So Leonardo, what would change now? Look at it good. Look at it good. It's starting at what now? What temperature is starting at? -10 degrees. That's okay? So it's starting at -10. So can I start it here? At 0? No. The graph will have to change a little bit, right? Right? It will have to start here all the way down here at -10. Right? So we have a slight problem. When you apply the heat, David, what do you think will happen first? When you apply the heat at -10 degrees, what will happen to it? Go up to what? Very good. So it will not undergo a phase change. It'll undergo a temperature change. Okay? Because ice only melts at what temperature, Leonardo? No, ice at 0, right? Okay. Ice already. So when it melted, it's not 0.
So when my eyes is melted, it's still be.
When it ice melts, when it's here now. When you melt to change temperature. Right? Why you online things from the NBA? Oh yeah. Try part 1. Try part 1. There's nothing matters zero. Fine. Oh yeah, try part one.
It's not about what it's nice. Right? The one that was temperature. Okay, so what?
That question was.
I got the ice and what's actually. It's still what it takes temperatures, and we're changing temperature for what's our own.
Hurry up, try part one, right? Find the heat energy. Find the heat energy required to change the temperature from -10 to 0 and back behind as well. What's the name again? Yeah. Lakshmi has mouth here now. Part one. Which formula Lakshmi going to use? Look at it. Look at what happened there. The energy required to change temperature from -10 to 0. So ask yourself, temperature change or phase change? Which one? Temperature change, right? Because it went from -10 to 0. Right? So which formula you'll use? The phase change formula or temperature change formula? Right? Okay? So find out what is M, find out what is C, find out what is temperature change and work it out. Upside down have 0, 0, 5, 2, 5. Huh? Upside down have 0, 0, 5, 2, 5. Get upside down.
Yes.
Am I correct? Correct. Take your time, use the formula, plug in the values, right? Oh yeah, work it out. And then please get a calculator. I see some of the solution on the source, right? Yeah. Get calculator. Yeah, calculator. Right, that calculator I told you. Start to use it exam. Anybody who I didn't jump physics again? 1, 2, 3. Right? Make sure you come to that class in on the group there, right? I think that is the last week of December. Huh? Only have one type C here. Permission to select it. Right, this person has more class, right? So I'm gonna go to the first part now. So part one, as Lakshmi said to use E is equal to MC delta theta. She said that the mass is at 2.5. What's the value for C again? C is what? Because it's what? Ice. Very good. Right? You're not using water because we're using ice undergoing temperature change, right? Anybody else think of the example they have?
Yes, one, Peter and Fritz. Just, yeah, so the three more, 1, 2, 3, 4. Nobody else, right?
Right? And the temperature change is 10 degrees, right? Don't write minus, right? 10 degrees. Okay? And how much is that? How much is that? Upside down? 2 zeros? Next part, temperature change is 10. I didn't use the village. But the break, I know. Ahora toque su. What's the name of the this one? Yeah. No, well, one. I'm like happy, but I want to get that. That's not kind of. Or that's. Well, he can't. But I can't. Next part, let's go again. Oh, one more paper. You'll need those values. Just screenshot or write them down now. Right? You'll need these two values here. Write them down fast. You know how to speak, you can write it up, but they need it. Write it up. No picture, no picture. Write it up. Write down these two values here. Two, but you used one already. Oh gosh. Oh gosh.
Well, you.
That's right. That's right. That's right. Right, we just with I. Online all okay? And talk to all the pretty holding. Narayan, you there? Narayan, you there? Sure. Why do you come down the road again, boy? And put us all accent for you. Right, specific heat capacity. You don't feel to wake up. Right? So you do be waking during that time, during that maths. That's right there. All right. All right, let's go again. How much more energy is required? Sure. Any wrong question? Oh gosh, a lot fancy. Hold on. If I didn't make it up, I would. Oh crap, boy. I thought that, sorry. I lost that. All right, sorry. All right, how to make it up, right? I don't know how yeah, let's have all these questions. All right. So most likely the next part was find the heat energy required. Find the heat energy required. Yeah. That's part two, right? Find the heat energy required to melt the ice at 0 degrees. Find the heat energy required to melt ice at 0 degrees. That's part two. That's part two. And the part three. Find the heat energy required. Find the heat energy required to change the temperature of ice, of water at 0 degrees Celsius, to change the temperature of water at 0 degrees Celsius. The steam, sorry, forget that steam. Good thing this one was steam because they didn't give you vaporization, right? Find the heat energy required to change the temperature of water at 0 degrees Celsius to water at 50 degrees Celsius. Right? Do part one and two. It had part three. I think it was finding total energy required. Remember? And part three finding total energy. Sorry. Part four. And part four finding total. So listen again. Part one, we did it already. Part two, find the heat energy required to change the to melt the ice. Step three, find the heat energy required to change the temperature of the melted ice of water at 0 to 50 degrees. And part four, find the total energy required. Hurry up. Then I'll give you the next one. Got plenty more. Two more and then I'll some other one. Right, then check it out now. Wanna get through? Right, so the next one will be a phase change, MLF. So that'll be 0.25 by LF. LF is 3.3 by 10 to the 5. How much is that? How much is that? 0.25 by 3.3. It's not, oh, sorry, I did the wrong thing. 2.5. The last one was 0.25. 825, 3 zeros. Nice. Next, temperature change. So the formula we're using is what again, Jaden? Temperature change. Oh yeah, that's kind of coming. That's right. E is equal to what? M C delta theta. M is 2.5. Temperature change is 50, right? And specific heat capacity is 4.2 by 10 to the 3. Right? And multiply it out. And then add them up, right? Okay with that? One more and then we'll stop, right? One more and then we'll stop. Make everyone have all the parts. Media, no problem. No problem. People want medium, the people get it. Yeah, Alex? And up your there, the last part, right? And about 3 values, right? And about 3 values to part 4. Right? So if you look at the earlier years didn't break it up in 4 parts there. Earlier years, it's like the first one I gave you, find the total energy. Right? The one I'm going to give you now, they break it up here part by part. Okay? All right, one, yeah. Okay, plug it in. 4.2, right? Don't put 10 by, right? Put 4.2 exponent 3.
Last time I had
That's what exponent. All right, let's go again. Let's get the other medium. Well, say medium. But you can see the values, yeah? Yeah, well, yeah, bring some money and buy a passport book, right? I'll organize one for it. So you gotta go through this again. Huh? I know you do it, but then you'll be on your phone and when they get a message, you reply and all that. Last one, last one. Oh wait, they can't do this one here. Because I'll show you the values first. Write those values, please. Write the values and put them there. C, L, B. Write those values down, C and L, B. Right, then I'll go back to the top. right? Please learn that value for C, right? Because there are questions that'll give you the other way around. They'll give you the energy and you have to solve for C. Okay? So it's good if you know what the value looks like. Right? Yeah. Go ahead. That's why C is for 200 and LV is 1. You know? All right, any whole thing? What's the thing now? Right, so. All right, let's go. Let's this. Have a third part, right? The third part is water to steam. Third part is the water to steam. Right? Third part is water to steam at 100. Last question. 5 minutes. Starting now. Alex, you do it one first. Alex, what can I do? Alex. Huh? No, for the company. Oh, we are in, anything I take. I think I think. Next one is water to steam. What I'm missing? To steam. Water from 30 to steam at 100. Water 30 to steam at 100. Last 2 minutes. Then Alex will help us. How are you doing part 3? It went from water to steam. Think about it. So when you're at 30 and you heat it, it'll go to what? When you heat the water, it'll go to what? 100. And when you heat the water at 100, it'll go to how many phases? 2, and temperature change and then phase change. So there's 2 sets of calculations. Don't overthink it. Right? Don't overthink it. We look at part 1 and 2. Finish? That's it. All right, so let's see. Water from 30 to 100, temperature change or phase change. So it's MC delta theta. What's the mass again? 1.5. Specific heat 200 and change in temperature 7. How much is that? 4. Nice. Part 2, that's part 1. Part 2, temperature change or phase change. It's going now at water at 100, the steam at 100. Phase change. So that's MLB, right? So that's 1.5 by 2.3 by 10^6. How much is that? 345 and 40, right? You leave your answer in standard form to 1. But here what they want last. Yeah. So it's on a 3 zeros or 2 zeros. Right? And part 3. They want to go from water at 30 to steam at 100. Yeah, just add the 2 values, right? Just add them. So that's technically total energy. So you add your 441,000 and your 34500. That's it. You get your answer. All right. We'll stop there for today. Right? Lab people take a 5-minute break, 10-minute break, and then we start. Right? Online. So you're looking at the values. Good, okay? All right, nice.
Sorry, don't forget.